Ohm's law. Okay, this George Simon Ohm, he was a German physicist, and he was the first person to establish the relations between the potential difference and the current passing through the conductor. Okay, suppose this is a conductor and it is connected to a cell, okay, having a potential difference V. When I say potential difference V, means the amount of work done to carry a charge from this point to this point, it is equals to V. Alright? Okay. Suppose the current that is passing through this conductor, it is I. Then this relation that George Simon Ohm has found, now it is, popularly known as, or commonly known as, the Ohm's law. And according to him, he found that this current which is passing through the conductor, it is directly proportional to the electric potential between the ends of the conductor, which means if you increase the potential difference, okay, between the two ends of the conductor, then this current I that is passing through the conductor also will increase. Fine. And if you decrease the current, if you decrease the potential difference, the current also in the conductor will decrease. That was first established or discovered by George Simon Ohm. Okay, and with some condition he found this, that when the temperature and pressure like strain and all are constant, that means these external factors do not affect the conductor, then this is what he found. Alright, or I can say here that if I is directly proportional to V, then I can say V is directly proportional to I. Or if you remove this proportionality sign, then you have to write some constant, okay, times I. And the constant that George Simon Ohm here, he represents with the letter R. Okay, so instead of constant we write R times I, this. So this R, now it is equals to V by I, right? And this R here, it is a constant of proportionality, and the name of this constant is resistance of a conductor. Alright, okay. Now when you look at this equation 1, right, then if you plot a graph between the potential difference and current, taking the current along x-axis and the potential difference along y-axis, then the graph here comes out to be a straight line, which means when you increase the current, potential also increase, okay, like this. So as you increase the current, or as you increase the potential difference, the current also increase, so therefore you will have a straight line like this. So please remember here that the graph between the potential difference and the current should be a straight line graph. Okay, and if I say this angle is theta, that means the angle made by the line with the x-axis, let's say it is theta. Now let's say at any instant, let's say at this point, if you consider this point on the graph, then if you drop this point on the graph, right, on the y-axis and on the x-axis, then you get this point. Okay, you get these things. Suppose this is O, this is A, this is B, and this is, let's say, C. So if you take tan theta from here, this tan theta, it should be EB by OA. Now what is AB? This AB is same as OC. And what is OA? This OA is actually the amount of current at this point. Okay, so this is what? This is a current. Again, tan theta here is nothing but OC. OC is what? Because OC, it is a point which is obtained by drawing, by dropping a perpendicular on the y-axis. So at this point you will get a particular value of potential difference, and for that we write it as V. Okay, so this tan theta is equals to V upon I. So looking at these two equations, okay, I can say that because R is equals to V upon I, tan theta also is equals to V upon I. So therefore, from the graph, this R is equals to tan theta. So please remember this equation. If a question asks you to find out the resistance from the graph, then that resistance is usually equals to tan theta. So by knowing this angle theta, then you will get the resistance of a conductor. Alright, okay. So this type of graph where you are getting a straight line here, it is not true for all types of conductors, because we have different types of conductors, like a conductor, semiconductors and all. So therefore this type of graph, it is actually valid only for those conductors which obey Ohm's law. Okay, like I is directly proportional to V. So for such conductors which obey Ohm's law, we call them as ohmic conductor. What is the name of conductor that obey Ohm's law? We call ohmic conductors. And those conductors which do not obey Ohm's law are called non-ohmic conductor. So when it is non-ohmic conductor, then when you plot a graph between the potential and the current, then the graph may not be a straight line graph like this, but you'll get a graph like of this type. Okay, so please remember this point here.